I'm pleased to welcome you for today's webinar, Deploy Big Data Solutions Rapidly in Cloud through Harbinger's ABC model. And I take great pleasure in announcing that we have attendees from almost 20+ countries joining us today. Let me introduce our speakers today's session. Dr. Prashant Harbinger, he is Vice President, Delivery at Harbinger Systems. Prashant brings in 27+ years of experience in industry and academia. He's the head of delivery and all our customers. He's also a certified Scrum Master. The second panelist for today's webinar we have is Umesh Kanade, who is the General Manager, Technology Solutions at Harbinger Systems. Umesh comes with 14+ years of rich experience and heads the activities in pre-sales, R&D, and technology leadership in Harbinger Systems. Umesh has been guiding light for many startups and in terms of product architecture and selection of technologies. We also have with us today Dr. Ashish Chokshi as the third panelist. Ashish is a solutions architect at Harbinger Systems. Ashish has 14+ years of experience in software engineering domain and is a passionate researcher with special interest in open source, web applications, and Agile methodologies. So without further ado, I hand over the presentation to Umesh. Over to you, Umesh.
Thank you, Mandar. Hello, everyone, and warm welcome to our today's presentation on ABC learning model for business data solutions, big data solutions. Harbinger has been into technology services since 1990, and with recent evolution of technology in big data space, we have newly experienced different challenges to accomplish the business and the technology objectives. The ABC learning model has emerged out as we were addressing these problems. So in this session, we'll cover what is this big data problem at hand and what is the ABC learning model, and then how it was applied in the real examples from the industry. So, and these two simple little words, big data, have made a lot of buzz recently. Big data is a term used for data sets so large and complex that it becomes difficult to process them with conventional data processing applications. So now, what is happening in the web domain is that web portals are becoming more complex and users want more dynamic contents relevant to their interests. Traditionally, we had a data tier called database and then an application tier also called web tier, which will be responsible for implementing the business logic, and then a client-side code that will typically run in client's browser to render the information in aesthetic and intuitive manner. The big data, on the other hand, has some other objectives. It is now becoming the new engine of business. So really, what has changed? Let us start with Ashish. Ashish, what challenges do you see for big data solution, and how is it different from the traditional approach?
Thank you, Umesh. And hello, everyone. Yes, Umesh defined very well the traditional approach to solve the business problems. We can visualize the business goals of traditional applications as a cuboid with several objectives. Here we go. The business wants the applications to persist the data, however large it could be. It was done by relational database systems. The RDBMS systems ensure integrity and timely availability of information. Business also wants to save different aspects of business transactions, for example, user information, their transaction information, the logistic data, or maybe the monetary part of the business. To achieve this optimally, data was normalized and was stored in tables, and relationship between records were defined by introducing primary key, foreign key associations. As things became more complex, we started seeing new patterns of business data. People wanted faster response on user interactions, and Ajax came handy to solve most of these problems. More varieties were still addressed by introducing some tables or more columns in table, and the increased data volume led to things like data sharding and clustering of databases. Now the model became successful, and the success of these patterns, business expectations are scaling to new levels. As you said, Umesh, the business wants to know sentiments of their customer about their products and services. They want to devise algorithms to recommend right products to their users, or thousands of users may be taking part in an e-auction or bidding kind of application. So overall, this kind of use cases have created new domain where there is a deluge of data called big data. The current data cube is up to something like this. We have very large volume, velocity, or the variety of data to be processed. Wikipedia defines big data as: big data is a term for collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. The common factors here is identification of 3 V's: the volume, variety, and velocity space of this data.
Okay, so having understood the big data problem space, mainly formed with these 3 B's, let's understand this why a model is needed to deal with these 3 talked about. Certainly in this model we see 2 technical aspects, but we will start with the major vital aspects of development strategy, makes us effective and successful. It is about achieving agility in big data projects. Well, the question is in the big data domain where neither the problem is well defined nor are the solutions. It perhaps doesn't take much to suggest let's get agile. But it remains to be seen how to get a team up and running to become agile. So Prashant, how do we really achieve this agility?
Thanks, Umesh, and hello everyone. We have already noted the 3 V's of data. From a big data viewpoint, there are many NoSQL technologies: key-value store, column family data store, document-oriented graph data structure. Also, new data processing abilities are being released constantly. And then there is the cloud, the advantages of which we will see shortly. The data scientists and the team have to learn these quickly besides learning the context of data as well as the expectations of business. We do this iteratively. So here you see the ABC iteration model. Our model is a way to learn the business problem and then to reach the solution space in an agile manner. A series of logical methods to create a social construct. Once I explain it, it will be clear that this is simple, but the results are wonderful. The iteration starts with a team preparing stories. These stories may not have clear value, may be contradictory to one another. This is because the business wants diverse things, and it's not very clear as to which is the best answer. Anyway, a particular story is picked up and data sets are created for that story. The people involved may be QA engineers, subject matter experts, or members of the performance engineering team. They create the large data sets as needed. This is followed by a research study on the implementation plan. The solutioning in the big data domain requires a lot more research based on trial and error. And this trial and error may often be at a low level. Once some tangible solution surfaces, solving some of the goals, we plan a team learning activity. The team is typically, as with any team in the world, a mix of experienced and less experienced engineers and analysts. The objective here is to share the knowledge obtained from the research so as to increase the synergy between all the members of the team. Then, after the team has learned, what we encourage is a group solving of the big story issue. So it's a collective ownership in the team to solve the problems. The team thinks on the overall story and its various aspects. Thinking as a group leads to innovative ideas that are transformed into some deterministic algorithms based on the technology or solution perspective. The next logical step is to build the related part of the product. Here we try to adhere to the good practices of extreme programming or pair programming, accompanied by constant code reviews, Scrum meetings, code check-ins, and builds at short periods, etc. Create a testable build which can be delivered to the quality assurance engineers. Then the QA engineers can perform tests. These may either be automated or they may be manual. The important thing is that it's not very clear as to what exactly is the best outcome. So it's a matter of evolution, it's a matter of learning here also as to what is giving us the best solution. Anyway, so in the overall iteration of this that we have seen so far, the testing may indicate that the solution to the original story may be valid or may not be valid. The solution is not valid, then we have done some learning as a team and we can start off a new iteration of the same story issue, same story. However, if the solution is valid, then we quickly deploy on the cloud so that the testers and users can test on real servers. We'll also come to the other advantages of cloud shortly. Now, what happens is, after this first iteration, we are ready for the subsequent iteration. And by this time, the business people may indicate desire for a better outcome. That is, increased complexity of the very same story that was taken up earlier. Or they may indicate a different story is of interest at this point in time. This story or stories may are then picked up and the iteration builds on top of the previous iteration. As more processing resources are required, the abilities of the cloud makes this whole thing viable. Of course, this still requires a lot of collaboration and decision making on the part of all the stakeholders, most important of them being the customer. Let's take an example case to understand this iteration cycle a bit better. Let's say that we have a challenge in recruitment analytics. The business objective is quite simple. That is, we want to get the right candidate for openings in an organization with reduced turnaround time. The turnaround time is the time gap between the time one publishes the opening for the job and the time when that job is filled up. Now, there can be many parameters while evaluating a candidate and attracting a candidate into the company. If you want changes, however, some of them are like enhancing the pay package of the candidates, providing flexibility in work conditions, or catering to other preferences of the candidates. Further, you might want to evaluate the experience and the usefulness of the candidate from various methods. One of the methods would be the candidate's professional connections, and to get their reviews into the candidate selection process. So now there is a big variety in the objectives, and this is essentially the big data problem. Now, so what may happen is that the first iteration may pick up professional connections as the story. Assuming that we go through the whole iteration and we get positive results on the story, business may change the number of desired professional connections. Or, separately, they may insist that flexible working preferences be considered now. This and now the corresponding data sets related to that would lead to the next iteration. So this is the overall concept of the iteration. Now an interesting question is, what is the time taken for an iteration? One may think that the research cycle may take a couple of weeks, followed by 1 or more weeks for each of the smaller cycles. However, what we have found is that because of the enthusiasm built by the learning cycle, the subsequent parts happen quicker, and the time taken for an iteration is 4, possibly even 3 weeks. The ABC model is a very effective model to learn the problems precisely and to come out with good results. So over to you, Umesh.
Thanks, Prashant, for such a comprehensive overview. So having understood the Agile approach, there is one more dimension of this ABC model, that is cloud. And as Prashant also indicated, the last crucial step in the iteration, which is deployment to the cloud. And every day, more and more IT applications are being deployed in cloud, and everybody knows that it's cost-effective way. It will only pay for the running servers and need not pay for the hardware when it is not in use. We can quickly expand or downsize our server infrastructure. The real question is, does it help our Agile analytics team in their objectives? So again, going back to Ashish. So Ashish, what do you see the role of cloud in ABC model?
The cloud, in fact, plays an enormous role in enabling the agility. As Prashant said, the whole idea is based on empowering each member of the team to understand what's happening. The cloud helps it further by extending the system to be accessed by client, by people who are geographically apart, and thus getting a strong collaboration, the sense of collaboration between the customer and the development team. And this is also a cost-effective and a manageable method. You really do not need a lot of IT people to manage server infrastructures. As Prashant said, the post-baby build needs to go to cloud. This requires few tweaks in the system to keep it free from dependencies. For example, if we have to scale the servers in real time, we may want to maintain the user session in different way. Or if it needs to run on several computing nodes, then we may stick to some distributed file systems. All such tweaks needs to be done in early builds.
So this is really getting interesting now. So with this, we'll come back to the big data aspect of the ABC model, where the major change is in the data layer. And relational data systems are great, and they cannot be replaced in their domain of maintaining the integrity of transactions. The big data, on the other hand, is often addressed by new constraint-free but scalable database systems called NoSQL. And NoSQL databases in different needs to be viewed in different contexts. So let's understand this now through the case studies. We'll take up the first case study from the volume space of big data. This is a case of large healthcare product company into clinical functions and related financial administration. In this system, the electronic health record of patients was maintained by legacy systems. Now, the volume of these records increased. It became sluggish to query the information. Other final aspects of the business problem is, while the records are queryable on the whole, queries to fetch records with some finer details within the description becomes very slow. And particularly when we can say that the records now cannot be queried. Business also wants to connect operational, clinical, and financial properties of each record so that these become queryable in runtime. Or the information needs to be exchanged through mobile devices also, thus adding one more dimension of interoperability of the presentation layer. The application needs to be cost-effective, and hence cloud-based server infrastructure is also desired. There were some other aspects of challenges as well. For example, there was a large part of the records that needs to be kept confidential and private, that is not to be shared, and this was also expected to conform to legal frameworks like HIPAA. So Ashish, so how ABC learning model helped us in this context?
Yes, Umesh. If we look at this problem through our ABC learning cycle, here we go. We quickly realize that there are many business objectives and goals are not deterministic. So we decided to attempt the simplest use cases first, then to evolve to finer aspects of the business problems. Going by size and volume of the data, it was decided to migrate the legacy application to Hadoop platform. For ETL, we first explored some frameworks, but then we felt that it will be a lot better to write our own custom implementation. For searching, we decided to use some open source libraries like Apache Lucene based Solr. In the islands of clouds, we explored Amazon Elastic MapReduce service. We started with a couple of data nodes, and then we gradually increased the size as more data was passed in. Coming to the technical solution, okay, we put ETL components to parse the records, validate them, and write them into the HDFS running on several nodes. We leveraged the streaming APIs of Hadoop and wrote MapReduce classes to implement the business use cases. Now, this can be run dynamically on data nodes and making all the records queryable as business desired. The system thus implements an efficient communication between the healthcare providers and the consumers of these services. Hadoop API gives us access to the MapReduce engine, which we really don't have to worry about where the data is going on to the respective data nodes. Right? So if we look at high-level solution, we have the scaling problem solved by a Hadoop distributed file system. We have Apache Solr that was found to be a good choice for relevance search. We address the issues of maintaining privacy and HIPAA compliance by writing custom ETL jobs, identifying the sensitive information. And this is where the existing ETL frameworks were first explored, but then they were found unfit for our solutions.
Okay, this is great. So we should now examine the velocity space now. The problem here is people want to get synchronized with the solution in an extremely fast manner. This may be solving a traffic problem in real time. Information needs to be exchanged in a fast and so fast that it should make sense before it becomes useless. For example, in our next case, it is in bidding domain. Some social events, users bid on participating resources. For example, in an event pertaining to sports tournament, people may want to bid on certain team and can start buying or selling something like contracts. Event may be anything of social nature. Let's say, for example, a live TV show, which spawns over several sequels. The business challenges here are, first, the user should be synchronized in real time. If a user bids and gets a delayed response, let's say by 1 second, well, then it's not a fair deal. So information needs to be processed before it becomes stale, meaning in very few milliseconds. The next challenge is to manage IT infrastructure. It is obvious that the usage of application will show high spikes with some popular events, and then there may be other times when we may not have much user load on the server. So over to Ashish again. So Ashish, now if you can explain on how ABC learning model again helped us in this situation.
In this project, the crucial factor, as you said, is velocity, or the rapid resolution of business transactions. How rapid and how fast was really not understood in the beginning. All of us were in agreement that let us make the system as fast as possible. Now, we really cannot trust some technical design telling us that this will be the fastest or the faster algorithm or technology to solve the problem. We decided to do some quick proof of concepts for each of the user stories, and this helped us in selection of technology and in system architecture. To achieve a hyper-responsive transaction velocity, we zeroed on identifying the context of the transaction. This is worth noting that big data need not have big context. Essentially, here it was about buying or selling. We found that context data was so small that it was a lot more efficient to exchange that than carrying out Ajax-based request response and callback model. So we used HTML5-based WebSocket, and over the WebSocket we pushed the context data to thousands of devices in around 280 milliseconds. To manage user transactions, we decided to do it on an in-memory database. Our choice was Redis, while overall data was managed by MongoDB through document-oriented structure. As you said, Umesh, there was a challenge to manage servers under high user loads, which spikes during certain events. The obvious choice was cloud-based servers, where we could scale the application servers automatically as the server-side resources consumptions go high. So overall, if we look at the technological choices in this project, we see that for HTTP push and notifications, Node.js and Socket.io made a good use. These provided the implementation of WebSockets across all browsers through JavaScript. An MVC-based application architecture was chosen, and we selected Grails as our technology to code the business logic. Grails is an application framework written in Groovy, which is a superset of Java. The framework is known to give rapid development velocity that helped us become agile. Other good things with Grails is it gives us ready interface for REST-based services. Thus, we could quickly expose some of application's resources to REST-based web services. This also provides a ready support for mobile devices. The application was then deployed on Tomcat servers and Amazon Cloud.
Wonderful. So moving on to the third dimension of the big data, that is the variety space. The challenge in this space is, as you know, the data has variety and it's not easy to fit the data into a conventional structural format. So NoSQL database seems obvious choice. The question is, which of the existing NoSQLs and how? The case study is from a talent management domain. The business challenge was to record all possible professional and personal relationships between a social group. So based on the relationship, it should help users to discover and connect to the people of their professional interest. And thus the challenge is to write a recommendation engine and to provide an interface to users that is most appropriate in users' self-context. The next big business challenge is to offer this application in a software as a service flavor, which requires two multi-tenancy to be implemented at data layer. Now, if we do this application with traditional RDBMS approach, we know that in advance that the SQL joins will perform poorly and could lead to a frustrating user experience. So I want Ashish to describe this case on how did we really solve these problems and what were the choices of technology and what was the delivery model.
Yes, Umesh. This project involved a lot of innovative ideas and design hacks. We have used a relational database to manage users and their roles and permissions. But to manage the rest of the information, we have taken up graph databases. We found through some rounds of iterations that Orient database fits our requirements very well. For relational database, Postgres SQL was good choice as we could create multi-tenant schemas and thus physically isolating the data of each tenant organization. Now the business data has been modeled in graph structures and Gremlin-based recommendation engine has been developed to provide searchability and look-ahead features. Cloud as a delivery model has been a great advantage as our client would understand us better by working on the same builds and thus strengthening the collaboration. To summarize, on business and technical implementation, multi-tenancy model was implemented in Amazon Cloud using Postgres SQL. A second tier of database was added and it was a graph database. We selected OrientDB for this purpose. The application logic was written in Ruby on Rails. The Ruby on Rails is known as the first choice of technology for Agile developers. The front-end web servers was Nginx. We used S3 for storing huge user files and artifacts. The application servers conform to auto-scaling designs in cloud right from the first build. The Rails also provided REST-based web services which connected a lot of user-side application features to Ajax. In presentation layer, the challenge was to design a responsive app that could be viewed equally well on mobile devices. This was achieved by using vector-based E3 and SVG along with Viva Graph library.
Excellent. So, to conclude on our work of implementing the ABC learning model, so we presented the case studies from all the three phases of the big data. So we saw each big data problem is characterized into the problem cube of 3 V's, and each dimension can be addressed with the right set of technologies to achieve the business goal. We saw that for large volume challenge, you can distribute and process the information with MapReduce. And in case of velocity needs, the speed can be better achieved by cached in-memory store of information, then pushed to users instead of queried from the store. And then we saw that the variety of data efficiently stored in non-relational schema to retrieve data and its relations much faster. Also, Prashant very well described the process of achieving the goals the ABC trade view model. And we saw that the right choice of technology was not revealed until the right need is discovered in the learning process. The ABC learning model helped it to discover over multiple iterations, and as complexity grows with every cycle, the scaling up is achieved with the cloud and validated at the end of each cycle. So ultimately, the solution emerges where the data is analyzed to discern patterns for better decisions, and this really has become the basis of competition and growth for businesses. Businesses can really aim to enhance the productivity, create significant value by reducing the waste and increasing the quality of the products and services. So with this, we are coming towards the end of the presentation. Over to Mandar.
Oh, thanks, Umesh. Wow, that was a very detailed and great session. Thank you, Prashant, Umesh, and Ashish. I'm sure audience too is pleased with such a rich and insightful session. We will be taking some questions from the audience now. I remind you to once again to if you have any questions, queries, please type in the question pane on your right side of the screen. And if due to time constraints, if we are not able to cover your questions in today's sessions, be assured that we will definitely send you the Q&A document, which will cover all the answers to all the questions that are raised today.
I see this first one on how is this ABC model different from the traditional Agile iteration model? So maybe Prashant, you want to take this up?
Sure, Ramesh. So the traditional Agile model is a set of user stories kept in a backlog. The backlog is ordered by value, and that backlog is kept on being updated. Typically, there is a set timeline for a sprint. It can either be 2 weeks, 3 weeks, sometimes it can be 1 week. The main difference in our ABC model is the fact that the entire team learns the business problem and the solution. So the business problems, first of all, may not have proper value, and the solution may not be known, but the part of it is to learn that business problem itself. And once the solution is found, or a glimpse of a solution is found, then we do the team learning. Because of this, there is empowerment of all members of the team, and then they participate in the ideation phase before the building of the part of the product which deals with that particular story. So what happens is that a strong communication, a strong bond is established between all the team members, whether they be designers, architects, developers, QAs, and so on. And because of this, and because of the enthusiasm built on this, we are able to get this whole overall solution out very quickly. And the important point is that the cloud is an integral part of this model. So it's not an afterthought, and it is there in every iteration cycle, and that cloud enables us to go from the one iteration to the next iteration. So these are some of the main differences from the traditional Agile method of development.
Thanks, Prashant. Next one I see on is it that every NoSQL problem is a big data problem? Interesting one. So probably Ashish, I mean, is there really a fundamentally different thing on technology side? I mean, what's your review on that?
Oh, well, this may not be true. not each or not every NoSQL implementation can be categorized as a big data problem. But you have an answer there. As we defined the big data in the beginning, that cannot be easily solved by commodity servers. We start looking for other options. NoSQL, if selected and utilized in correct manner, can be scaled to a big data level without making any architectural or functional changes in your application. And we have also noted that while NoSQL provides attractive alternative to relational databases, this cannot replace them. Options like in-memory key value stores like Redis and document-oriented databases like MongoDB or distributed file systems like Hadoop has changed the whole approach, and now there is a new way of thinking to solve the business problems. I hope I have answered your query.
Then there is one question on some data visualization in our big data system. We are considering some existing frameworks like Splunk or Table. Okay, so have you tried these? Maybe I'll take this up. I mean, it is possible that the existing frameworks or solutions may fit exactly well in your requirements. In such case, it's an excellent choice to use a ready product. However, if you have to change or modify your requirements of data visualization for some business purpose, then probably our recommendation is to consider reviewing your decision, because then it's over a period, the approach tends to fit into what is really feasible in that tool. So we are inclined to suggest that go for a custom solution where your business context is understood first, and then solution is arrived at using some methodology, or once more the maybe the ABC model will help achieving that. And then we have a question on the process part, and saying that are all people doing research or waiting for researcher to complete in the iterations at the same time? Prashant, you want to comment on that?
Okay, so whether all team members are waiting on the research cycle to happen, and then what are they doing during that time? Okay, okay. So yes, a team may have multiple people, say 15 people, 25 people, and the people who may be involved in researching one story might be 3 or 4 people. So certainly the rest of the people are not waiting. They are either continuing with normal user stories, which are also part of the overall solution, and so they may be at various points. So they may be either building part of the solutions or testing them and making sure that those are complete. Another very open possibility is that there are multiple iteration cycles going on in tandem and maybe a little bit offset with one another. So let's say it's, a team starts on Monday researching user story 1, and they are in the research cycle for a few days. It is possible that after 3 or 4 days, another user story also needs to be investigated, and a few other people start researching that user story. All people come together for the learning aspect and so on, of course, but it is possible that there are different iteration cycles offset in time. So this is a bit unlike the traditional sprints, whereby essentially all the team members are locked into a particular sprint and the end of a sprint. This may seem chaotic, but the advantage is that various research issues get taken up, and are handled and the solution is provided, and finally the team all comes together for the overall product. So, essentially all these things get coordinated by the team members themselves. I hope I have answered the question.
Certainly, Prashant. So let's quickly take some couple of more. So one is, in your opinion, what classifies the data as big? Maybe Ashish, you want to?
Yeah, right. Okay, so we have been discussing about big data, and seems as Umesh says, it's a big buzz. So there is a lot of confusion about what classifies big data. Some say that it's a terabyte of data which makes it a big data. So we say it like if we cannot process the data with our traditional implementation, then we can call this data as a big data thing. Okay, it need not be a terabyte or gigabytes of data. It can be even, let's say, 10 megabytes of data which needs to be processed in few milliseconds. And if your application is unable to do this through your traditional approach, well, this is a big data problem. Like so we have to devise some methodologies, some new technologies, and some new comprehension about the whole business problem. Why is it required in some manner? And that's how, as Prashant said, our ABC learning model will first learn the business problem, and then we will, in collaboration with business, will devise some approach to solve it.
Okay. Absolutely.
Right?
Absolutely. And let's take one final one, which talks about, can you please re-summarize the businesses which are likely to be benefited by each dimension of big data, the volume, velocity, and variety? I think we covered primarily the three scenarios already in the presentation, which one was the healthcare scenarios where large sets of record sets needs to be processed and in a more real-time scenario. And there situations could be in the consumer internet where the velocity matters, and those are what we saw, which are real-time event-based systems, which would require response times in fractions of seconds from large chunk of small data to be retrieved. And the variety is where, I mean, anywhere any enterprise has asked demographic information to any sets of maybe from the HCM or HR specific to learning specific to anything related to employees and the users of the systems used across the enterprises. So that is very difficult to confine in a schema restricted stores, and that's where the need for addressing the variety as a challenge through the NoSQL solutions really matters here. So I hope I just addressed your question on the businesses aspects. So with this, probably we have the time constraint, so we need to pause here. So Mandar, over to you.
Thank you, Umesh. And just a brief note, today's webinar is being recorded, and all the attendees will receive an email with a link to view a recording of this event, along with the question and answers document. Finally, I will request you to please fill in a short feedback survey form that will pop up on your screen once you exit this webinar. It won't take long, but will surely provide us an important insight on how to improve and what topics to choose from in the future webinars. With this, we conclude today's session. Once again, thank you all for joining us, and have a great day ahead. Thank you.
Thank you.
Thank you.